We're going to spend another day working with complex numbers, and specifically we're going to work with this idea of a complex conjugate. When we talk about complex conjugates, we are basically talking about a difference of two squares. So if I have a plus bi, which we said that's kind of the standard form of a complex number, well then a plus bi and a minus bi are complex conjugates. And the reason why complex conjugates, why the conjugate is so important, is because of this. If I multiply a plus bi times a minus bi, a binomial times a binomial, I think you see that this is going to be a difference of two squares. So I square the a squared, minus I square the second term, which is going to become b squared I squared. And immediately we see that something happens. What happens to the I? It goes away. It becomes a negative 1. So since this becomes negative 1, what we wind up with is a squared plus b squared. And notice there is no I. All right? And so that helps us in some situations that we're going to see today. Okay? So let's get to some examples. First, they're going to ask you to find the conjugate of the complex number and multiply. Find the conjugate of the complex number, and then we're going to multiply the two together. So they'll give you some easy ones, like this one, 4 minus 3i. All right? So what's the conjugate of 4 minus 3i? Yeah, 4 plus 3i. No tricks. It's 4 plus 3i. So this right here is what we would call the conjugate of 4 minus 3i. Okay? And then the multiplying part is just the difference of two squares. I know I'm going to have a minus between the two. It's going to be 16 minus 9i squared. And what's I squared? Negative 1. So this becomes 16 plus 9, which is 25. Okay? Sometimes they'll just give you something like this. The square root of negative 24. And you might be thinking, well, how can I write the conjugate of that? Well, I'm going to show you. First thing we want to do is take our I out. Okay? So let's take our I out, and I have the square root of 24i. I'm going to write it like that this time. Well, how would I write that as a complex number? I told you the other day that that would be 0 plus radical 24i. Right? So then the complex conjugate of it would be 0 minus radical 24i. I mean, we know what's going to happen to the zeros. I'm just putting them there so you understand. Okay? Obviously, when we do the difference of two squares, 0 times 0 is 0. All right? So we don't even have to write the 0 squared, do we? But you do need to pretend it's there, because this is still a difference of 2 squares. So it's going to be 0 squared minus, what's the square root of 24 times the square root of 24? 24 I squared. Yeah, we're kind of pretending that there's a 0 here, okay? Even though 0 squared, technically, okay? Because we're just using the difference of 2 squares shortcut. We're not really, we don't even need to FOIL, okay? So then the I squared is negative 1, and this, my final answer is positive 24, okay? One more of those. It seems like if I don't go over this one, people don't know really what to do. What if they give you the square root of 12 and they say to write the conjugate of it and then multiply? Well, sometimes I know books kind of give you problems that sometimes I even wonder, what's the point of this? But I need to show you what to do with it, because it might show up in homework. This is the same thing as the square root of 12 plus 0i, right? So then what would the conjugate of it be? The square root of 12 minus 0i, right? Now obviously, if you square 0, there's nothing there, right? So really, we don't even have to do anything with that. This would be kind of my conjugate, but when I multiply these, all I'm going to wind up with is 12, because I have the square root of 12 times the square root of 12. All right, the 0i's don't matter. Okay? All right, where we're going to spend more of our time is with these examples. Write the quotient in standard form. Okay, well, I need to give you a couple of notes here before we ever start. So the first note. We will multiply the top and bottom by the conjugate. Okay, and it's kind of like rationalizing the denominator. Okay, when we did that with our radical problems, it's the same idea. We want to get rid of the square root of negative 1, get rid of the I in the denominator. And I want to add another note that will show up here in a minute. Okay. And it's going to apply to one of our later problems. If the denominator has an operation, do the operation first, then multiply by the conjugate. I know that's a big, long sentence, but I think it will be helpful here in a second on one of the problems we run into. All right? So what we're doing is we're getting rid of the I in the bottom. Let's get to some examples here. Oh, well, I've already got the example written up there. Here's number 1. 7 over 8 minus 3i. So if I see that situation, I want to get rid of that I in the denominator. So what I do is I follow my instruction up there. I'm going to multiply the top and the bottom by the conjugate of 8 minus 3i, which is 8 plus 3i. And what that's going to do is it's going to get rid of the I in the denominator, because now what I have is the difference of 2 squares down here, and that's going to become 64 minus 9i squared. Don't skip steps on this. You'll mess it up if you do. Okay, people all the time try to skip steps and then they get wrong answers. On the top, you need to do distributive property. So that will become 56 plus 21i. All right. On the bottom, we're just about done with this problem already. Isn't this the same thing as 64 plus 9? So my final answer then would have a 73 in the denominator, and then on top I would just have 56 plus 21i. And we have taken care of getting that I out of the denominator. That problem is done. All right? Let's do another one. How about 8 over I? Well, what is the conjugate of just I? Negative I. So we're going to multiply the top and bottom by negative I. Okay, just by the conjugate. So on the bottom, I have negative I squared. On top, I have negative 8I. Well, negative I squared is the opposite of negative 1, which is positive 1. So this is just, this thing right here is positive 1, so this is just going to be negative 8I. Okay, pretty easy. Moving right along. How about this one? 2 plus 3I over 4 minus 2I. Well, this one looks pretty normal, but we have to pay attention with what's going on in the numerator. So I'm going to multiply by the conjugate, 4 plus 2I over 4 plus 2I. We may as well, I'm going to run out of room going off to the right, so I'm going to come down here. The denominator is going to be easy. That's going to be 16 minus 4I squared. That's our difference of two squares down here. On top, though, we have to do FOIL, because I have two totally different binomials multiplied together, so I have to do FOIL there. So that 2 times 4 is 8, the outside terms plus 4I, the inside terms plus 12I, the last terms plus 6I squared. So from there on out, it's just kind of some cleanup detail. The denominator is going to become 20 because that's 16 plus 4. This is a negative 1, so that makes this like a negative 6. So 8 minus 6 is 2 plus 16i. Now I will tell you that if you check your answer in the back of the book, that's not good enough. Does anybody see why? Because I can do some reducing. I can factor a 2 out of the top and make it 2 times 1 plus 8i over 20. And then I can factor the 2 and the 20. Okay, so it's the best answer, the best final answer would be 1 plus 8i all over 10, like that. Okay, so that shows up some. All right, the next one refers to our second note that I wrote a second ago. 7i over 9 minus 6i quantity squared. You remember the second note I gave you said if there's an operation in the denominator, do that first. So you don't want to multiply by 9 plus 6i right here. It just won't work. You want to go ahead and multiply out this denominator, which, remember what this means. We know the square of a binomial shortcut, which says I square the first one, 81, I square the last one, plus 36i squared. 9 times 6 is 54, times 2 is 108i, and it's going to be negative. Now, of course, I squared is negative 1. Okay? So this denominator, I'm going to come down here, this is like a negative 36. So 81 minus 36, isn't that 45? So I'm going to have 45 minus 108i on the bottom. Okay. On top, I still have this 7i. Okay, so you have to do that first before you multiply by the conjugate. All right, from here on out, it's just like the last few problems. I would multiply the top and bottom by 45 plus 108i. And then I would finish up the problem like we did before. Okay, so I'm not going to finish that problem, but I wanted to show you how we started it. From there on out, it's like we did before. I wanted to get to this problem, which is one of the reasons why I didn't finish the last one. They're going to tell you to perform the operation, which is basically just addition, but we're going to have to deal with denominators and fractions. So if I'm going to add two fractions, don't I have to have a common denominator, right? And in this case, this is going to come back to something we learned earlier in the year. What is the LCD? 3 plus I times 3 minus I. So this is not an equation. We're not getting rid of fractions. We're just getting a common denominator. So I'm going to multiply each fraction by the piece up here that it doesn't have. So this first fraction, it needs the 3 minus I. So I need to multiply top and bottom by 3 minus I. The second fraction needs the 3 plus I. So that's times 7 over 3 minus I. Okay. So if you look at this denominator, isn't it convenient that they're conjugates? Right? So the denominator is going to become 9 minus I squared, which is just 10. So my denominator is just 10. And then I need to do distributive property with everything else. So 3i times both of these, that'll be 9i minus 3i squared. 7 times both of these, that'll be plus 21 plus 7i. I've got an I squared, so that becomes a negative 1, so this becomes like plus 3. So I'll combine that with the 21, make it 24 plus 16i over 10. And I think I can factor out a 2, can't I? To simplify it. Make this 2 times 12 plus 8i. And then the 2's will factor. So this will be 12 plus 8i all over 5. Okay? Well, I could factor out a 4, but it's not going to help me any. You're right. I could have taken a lot more than a 2 out, but I paid attention to what I had in my denominator. All right? And I knew I couldn't do any more than what I did. What if they tell you to solve a quadratic? And if you remember, when we did the discriminant, we said the 3 possibilities for a quadratic were 2 solutions, 1 solution, or no real solutions. But there can be imaginary solutions. So let's go straight to the quadratic formula on this one. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And if I kind of do b squared minus 4ac in my head, b squared is going to be 4 minus 4 times 3 times 5. I can see that the discriminant is going to be negative. So there's no real solutions, but there are imaginary ones. So let's go through the quadratic formula. Negative b is going to become positive 2 plus or minus the square root of 4 minus, we already wrote it up there, 4 times 3 times 5, all over 2 times 3, which is 6. So 4 times 3 is 12. 12 times 5 is 60. So I'm going to have 4 minus 60, which is the square root of negative 56. And that's 2 plus or minus that, all over 6. So what I need to do now is just kind of deal with my I and simplify the radical a little bit. We're going to take our I out. Are there any perfect squares in 56? Just 4, right? So I can make this 2 plus or minus I times the square root of 4 times the square root of 14, all over 6. And the square root of 4 is 2. So now I have 2 plus or minus 2i radical 14 all over 6. Like I told you, they won't leave the answer that way. They'll take a 2 out of the top. So it'll be 2 times 1 plus or minus radical 14i, or I radical 14 all over 6. Do my factoring. Finally, this problem is done. 1 plus or minus radical 14i all over 3. Okay. Now the last thing, real quick, before we wrap up, is thinking about these powers of I. We said that I was the square root of negative 1, didn't we? Well, I want to show you a little pattern that emerges. I to the first power is I. I to the second power is negative 1. What is I to the third power? It would be negative I. Because it'd be basically these two multiplied together, right? So what would I to the fourth be? It would be positive 1. Now, guess what? This pattern repeats itself forever. Okay, you may have seen this before. So if I were to keep going here with these, I would just recopy. It just repeats itself. This will come down here. That'll be I. Then this will be negative 1. That comes down here. And this will be negative I. And this will be back to positive 1. Right? So what if they told you to find out what, for example, what if they said, hey, what's I to the 43rd power? Well, what you want to do is divide by 4, okay? Divide this by 4, right? And what will your remainder be? Isn't it going to be 3? You're going to have a remainder of 3, so you treat it like I cubed. Okay? So you go back to my original list. I cubed is negative I. Okay? And we'll stop there for today.